Good evening, everyone. My name is Ben Hall. I currently don't work anywhere, so if you're recruited, let me know. So all the slides, all the code samples which I'm presenting tonight will be found on my blog. If you've got any questions, then feel free to contact me on Twitter or via email, or just grab me during pizza and I'll be happy to answer them. So tonight, I'm going to be discussing IronRuby. I think IronRuby is really cool. And tonight, I'm going to tell you why you should care about IronRuby. All right? I'm going to try and convince you, try and show you some of the highlights and why you should start thinking about using it in your day-to-day life. So what we're going to get a little bit WPF, we're going to get a little bit PowerShell, a bit C#, and then we're going to kind of cover Ruby. The fact that it is IronRuby, we need to cover the Ruby language. So, straight into it. Reason one. This is something from Microsoft. This is not a kind of small little project which some guy in a bedroom has started. This is actually from Microsoft. Microsoft put their full weight behind this. And it's all part of their dynamic language runtime. So this DLR, which they're producing as a platform, is what IronRuby are actually building on top of. So they're taking advantage of everything, which means Microsoft has got a nice big team around it. The DLR is also what made IronPython possible. Similar approach. IronRuby is based on the Ruby language, allowing you to write Ruby code on top of the .NET platform. IronPython, same kind of thing, allowing you to write Python code on top of the .NET framework. Fundamentally, they share the same infrastructure, which is the DLR. Kind of as a sign of Microsoft's commitment, they are bundling they're bundling the DLR, or at least the core part of the DLR, into .NET 4. So when you install .NET 4, you will have the core bits of the DLR there ready and waiting for you to use. The aim of this is to make language implementers actually have an easier life because all the bits are already there. All the versions and everything is there ready and waiting for them to use. So what is the DLR? Well, I'm sure we're all familiar, or the ones of us who've done any .NET and C# programming before, about the CLR. The CLR is a common language runtime. This is everything which kind of makes .NET work, all the boring stuff which we don't really care about in .NET, things like garbage collection, exception handling, memory management. Everything in a nice managed world is now done for us by the CLR. The DLR takes advantage of this. It goes, well, we're not going to reinvent the wheel because we don't have time and we don't have money anymore. Instead, we're going to take advantage of this really great platform, which is now on version 4, and build on top of it. We're going to build a nice layer which is targeted for dynamic languages. This is how IronRuby and IronPython can work, because they've got this nice abstraction. And there's other languages. So Gary Shaw is producing Iron Smalltalk. He might say he's not, but really we all know he actually is. Reason number 2, it's open source. Everything about the language is open source. The DLR is open source, IronRuby is open source, IronPython is open source. Well, there's a couple of reasons why this is quite useful. One, it's MSPL. This is the most kind of open license Microsoft actually offers. It means that Microsoft, if you want to use it, if you want to go off and use the existing code base, which is there, and go off and do your own thing with it, Microsoft aren't going to stop you. As long as you do it within whatever realms the licensing says, Microsoft will let you pick up their code, what they've spent years working on, and just start your own project, which is cool. It means that if Microsoft decide that they're not going to continue doing IronRuby, the code base is still there for the community to pick up and actually run with. It means that you can put some faith in the platform which you want to use. And also, it's just an interesting language implementation. The code's C#, so you can download it from GitHub, have a play around, just see how they actually implemented it. As you see, there's 10 different projects there. It's quite an impressive language implementation. And it's just useful just to have a nose around to see how the bits are structured. Even if you don't plan on actually doing anything with it, just interesting to see how they've built the language. Reason 3, it's Ruby. I like Ruby. I think Ruby is an amazing programming language. It's part of the dynamic languages kind of collection. C# and VB.NET are more statically typed. This means that it's got the compiled and all the types are inferred at compile time. With dynamic languages, everything's more at runtime, and everything's a bit more fluid, and you can kind of do some more cool stuff with it. Many people say it makes you more productive as a result. But for me, Ruby is all about readability and testability. I think it produces much more readable code, which is good. You want readable code because when you come back to it in 6 months' time, then you can actually read it instead of thinking, oh my God, what the hell was I thinking at this point when I wrote this? Which is kind of how my C# tends to be. My Ruby code, however, perfect-ish. So, some Ruby syntax and kind of what makes it more readable. First thing is optional syntax. If it improves your code to leave bits out, such as curly brackets or semicolons at the end of the line, then leave them out. The language doesn't enforce you to put them in. Sometimes it makes sense for you to put the brackets in, sometimes it doesn't. And as I progress and show you more demos, you'll see why this is important. Or the declarations, you don't need to declare the type. The type is inferred. So in this case, x will still be an integer. It still knows it's an integer, and as such, it still has a type associated with it. It's just that the language is clever enough to infer that for itself. It means that, as a result, your code has got less noise around it. You don't have all these int x equals 1. Instead, it's just got x equals 1. Little touches here and there actually make your code more readable. I also find it's a much more natural way of programming. Everything seems to just kind of be more intuitive. Everything just works as you would expect it to. So here we've defined two arrays of numbers, and to add the two arrays together, we just use the add operator. Surely that's how you would expect to add two arrays together. In some programming languages, not the case. But in Ruby, little touches like this make things possible. Everything is an object. Again, little touches, but these little touches actually improve your programmability, improve your productivity, because things are just much more natural. So in this case, you've got a string, and you can call uppercase to convert that string into an uppercase representation. Sort onto an array, sorts the array. Then the third one is 10.times. Even though 10 is an integer, it still has methods associated with it. One of these methods is times, which accepts a block. A block is the equivalent to, say, a delegate or a lambda expression within C#. It allows you to pass in arbitrary bits of code which want to be executed in place. So in this case, times will execute the block, the arbitrary bit of code which you want to execute, 10 different times. It will just iterate around it. This is really useful because if you think of the equivalent in C#, you'd have to use a for loop. So you'd have code such as for int I equals 0, semicolon I is less than 10, semicolon I plus plus, and then put in your code. It's kind of a lot of noise just to say, well, loop something 10 times. In Ruby, you do just literally say loop something 10 times. Duck typing. So this is interesting. So because all the type is inferred, when you define something like a method, you can't define the type because there is no such thing, or the type is inferred. So in C# or VB, you're used to writing my method int accepts int x and int y. I can't think of variable names today, so we'll just work with x and y. With Ruby, you can't do this because you can't say int x and int y because that will be inferred by the language. And this is what allows for duck typing. Duck typing is basically, instead of what the type says it is, treat it as what the type can actually do. Do it based on the contract of that particular object. So with this method, as long as the object has a method called get_name, then it will work. It doesn't care if it's implemented the correct interface, or it's implemented the correct base class, all of this kind of fluff which you kind of have to deal with. If it has the method and it's called the correct thing and it's got the correct parameters, then just use it. Don't care about anything else. This really helps reusability of your code. For example, we've got a class here. Class A, define the method called getName, and this will just simply return a string, my name is A. We've got another one, Q. Does the same kind of thing, but says, my name is Q. Two completely separate classes. They could be in completely separate libraries, different frameworks, wrote by different authors. But they're related by the fact that they both implement the same name and both implement the same method. That means that in our code, we can pass new instances of these classes as objects into the method, and the code will just work. If you think about it in C#, where you've got many times where you have to cast and you have to convert different types, all of that's now redundant because, well, as long as it's got the method, then it will just work. I find it really useful. So along the same lines of reusability, we have libraries. So there's lots and lots of different frameworks out there which you can take advantage of and actually start using. All you simply do to reference those is say, I require this particular library. To get access to those libraries, you simply go gem install the particular library name. It will then go off, install the library, install all the dependencies, the correct version of those dependencies, any documentation which might be associated, and put it all into a nice place for you to find and start using. Now, if you think how .NET is, and how .NET assemblies are, and how we have versioning issues, and we have conflicts, and we have very little documentation which you can find, in Ruby, life is so much simple, because you just type it on your command line. In C#, you have to fight through 20 different websites, 10 of the links don't work, and then you get the wrong version anyway. A few things why I like Ruby. IronRuby, as a result, can take advantage of all of that. Reason 4, you can take advantage of .NET. So we can combine all of the stuff which we've seen before together with the fact that we've got the entire .NET platform. So, to start IronRuby, let's just load up. Zoom it at the same time. So I'm using IronRuby 0.6. It's still early, to say the least. It's definitely making stages, but it's still yet to reach that golden 1.0 release. And now we've got a complete interactive console where we can start writing code. So we can do things like, say, put hello world, and that will write hello world to the screen. So we've now started to interact with code. We can do things like the turn.times. That syntax, where I've got two vertical lines and an I, is just passing in an variable into the method. And as you'll see, if we do put I, that's just the count around it. So you can actually, in these arbitrary blocks of code, you can pass more information in, so you can actually take advantage of those. Little touches, but still very cool. And other things like, if you define a string, not what I wanted to do. Define a string, then you can simply index into that string, go 1, and let's just go 4. Now when you output that string, you can see that it's gone in, indexed it, done a regular expression, and actually matched the string, and replaced it for you. Now it's all very simple code, it's nothing complex, but these simplicities actually are really powerful when you put them together. So for example, we can read in a file, just by going file.read all lines, file1, 1.text. So that's read in all the lines of files from that, all the lines of text from that particular file. Can do the same for 2. And then we can start comparing the two files by simply just minusing the two arrays, and that will show what differences are actually in both the files. We can do things like intersection, so what's in file 2 but not in file 1, and then we can add them together and say what's actually in both of these arrays. The fact that it came from files are relevant, but these little touches of how you actually work with objects and how it's nice and natural is what makes Ruby a really powerful language. That's all cool, but we're .NET developers, I'm sure. How many people are actually .NET developers? Good. So we like .NET things. We've got the entire .NET platform to take advantage of. You know, we're quite lucky. We've got really good tool set. We've got really good frameworks such as WPF and Silverlight. These things aren't possible in Ruby. In Ruby, they have few web frameworks which are really good, but they have very little on the desktop. With IronRuby, they can require WPF, and that's now required the entire WPF library, so presentation framework and presentation core assemblers. And then we can start working with things. So we can do window equals system windows. Window, so we've now just created a window, a WPF window object, or we've just created an alias for it. These double colons are just how you can navigate namespaces. So instead of in C# where you use a dot, within Ruby and within iRuby to do the same thing, you use the two colons together. So we can do things, the same kind of thing for application. And the same kind of thing for a button. And then we can start interacting with them. So we can create a new window, and that will just create a new instance of our window object. We can set a title on that. We can create ourselves a new button. And now, the thing with events, and particularly button events, is that, well, to assign a button event, you would use very kind of targeted C# language. You'd have to create an event handler and actually assign it as you would. Because the team don't want to make Ruby developers relearn an entire different way of programming, they've actually made it so that you can use the Ruby type programming language and the same Ruby feel, but work with the same .NET kind of concepts. So events you can assign just as you would if it was a Ruby event. So if we assign the click event, then this accepts a block. So it's got the same kind of sender and args as you would expect. And we can navigate into system windows. Messagebox.show. Are you still Vista Squad? Yeah. Touch subject. So that's now assigned an event. From the Ruby point of view, that's just how Ruby programmers would expect things to happen. So if they're picking up these languages and picking up these frameworks to work with, such as WPF, they don't have to relearn an entire different way of programming. It just works for them, which is really powerful. We can now do things like give the button some content, and we can say click, and if we say window.content will be the button, and then we need the application object so we can actually start it, and then we can say a.run the window. And all being well, if I hadn't forgot a line of code, we'll get WPF window pop up with a button, and it's got a click event. So this is all created using WPF. From the user's point, created WPF and iRuby. From the user's point of view, it's irrelevant. But actually, if you want something quick and something quite simple to get started with, then you can use this. Now, if we're quite honest, until Blend or something actually has iRuby support, then we're not going to do this. But if you imagine that you're a Ruby developer and you don't have anything better, then this is actually a really powerful alternative. So for example, if we go into the samples and there's a disk usage, disk use. So this is an application built by the iRuby team, built using the WPF, just in exactly the same way I've shown you, which will actually monitor and show you how much space all the directories are taken. So it's a little bit flaky and it's not very quick, but it does prove the point that you can build actual real applications using these particular frameworks. It's not being very quick at all. Good. Moving on. We'll just let that sit in the background and do its thing. So, moving on. So that's WPF, but we can kind of get a much more closer relationship between different things. So the next thing I want to show you is PowerShell. So the team have created a sample. They've created a sample which is created in Ruby. Let's load that up using a better editor. There we go. So, as you can see, we're referencing MS Core Lib, and we're referencing one of the PowerShell core assemblies. And what this kind of PowerShell wrapper does is simply just hosts PowerShell within the IronRuby language. So there's quite a lot of code to it, which if you want to go in and you want to dig a bit deeper, then feel free to do so. But as you can see, once it's actually done and it's done its thing, then you can access things like commandlets. And you can actually start working with PowerShell commandlets out of the box, but within an IronRuby infrastructure. So for example, the team have created a nice little sample which goes off and gets processes using PowerShell. It will go off and get WMI objects and get you that kind of information. And basically it works with all the types of things you would expect from PowerShell, but allow you to interact with them as you would if you were just using normal IronRuby objects. This is actually quite interesting, because now we don't have this discussion between should I use C#, should I use Ruby, should I use PowerShell to do a task. Now we simply just say, well, PowerShell solves this problem. PowerShell lets me do this particular problem, but IronRuby will let me solve it maybe in a different way and maybe allow me to put it onto the web. With IronRuby, we can say, well, use both. Let PowerShell do your Exchange management servers and Exchange and SQL Server and actually all the management stuff it's really, really good at, but let IronRuby come along, host it into a web environment, and let IronRuby do what it's really good at. Each language now can do what they're really good at instead of being hacked and made kind of fudged in to do things which they wasn't really designed to do. I think this is really powerful, and I think this is where we're going to see lots and lots of key examples of this nice interoperability. So what we can do is we can run that particular example. One of the problems with IronRuby at the moment, which is really problems when you're demoing it, is it's a little bit slow. They've made huge amounts of performance improvements, but they've still got a bit to go before 1.0. But as you can see, we've now gone off to PowerShell, used PowerShell and WMI from Ruby code, and actually pulled back the bits of information we are interested in. Very cool stuff. So, that net interrupt, I think that's going to be powerful. I think that's going to be big, one of the big advantages. Next advantage, Ruby. Ruby has an amazing community. If you think .NET's good with its open source work and Hibernate and frameworks like that, Ruby is in a different league. GitHub is a centralized open source repository for lots and lots of source code projects. It's got about 100,000 users. If you look at the most watched, out of the top, say 10, 8 of them are Ruby-based projects. All completely open source, all where you can download, take advantage of and start using. In the same way, just doing gem install Rails or gem install Rake, start downloading and taking advantage of them from your application straight away. This is great if you're a Ruby developer, but it's now great if you're a C# developer, because you can start hooking into these. You can start using these powerful frameworks within your C# environment and in your C# world with your C# code. So let's take a look. So the first framework I want to show you is Sinatra. Let's come into here. And let's create a new Ruby project, Ruby program, and let's call this Hi. So Sinatra is a web framework. It's aimed at being very lightweight, but it's completely powerful at the other extremes. Very lightweight to get started. Okay, thank you for reminding me that. Very lightweight to get started, but complete scales up to and beyond where Ruby on Rails is. So if we can do things like require Ruby gems. So this is a packaging system for Ruby, so we can get access to all the packages which we've downloaded. and then we can say require Sinatra. So he's now got complete access to that particular framework. That's it. That's all the references. Everything else Ruby will work out for you. We can then go, so we've just created an endpoint and we pass it, and this accepts a block. So this is now going to be an endpoint for our web application. So when they go into a web server on our local machine and go /hi, that will direct them and execute whatever is in that block. If you think about this, get is a method with 2 parameters. The first parameter is the endpoint for your application. The second parameter is the block of code which you actually want to execute. But because of this optional syntax and because of the way you write Ruby code, you can drop these. And this is what improves the readability. And this is why having the optional syntax is actually really powerful. Because instead of all this fluff and noise, you can have that. I think that's much more readable. Subtle, but much more readable, makes the code much more flexible. And in this case, let's just do return the classic hello world. So now if we come back into our command prompt, .ruby, and I'll call it hi. So IR, you can either use interactive version just by typing IR and then you enter the interactive prompt, or you do IR, pass it a Ruby file, and then it will execute that Ruby file. So now it started Redbrick, which is a web server built on Ruby, and we can come in, open up Firefox. It started on port 567, and we can go localhost 4567. So it doesn't know it. If we enter the endpoint, then it's actually gone off. It's hit that server. So if you look at the logs, it's gone off and done a proper request to that server, gone into that action method, executed it, and then returned the results back to the user. It's kind of cool. I think it's a nice little framework. It allows you to be a bit more flexible with your approach and allows you to do some cool things. It's more cool if we just stop this by closing that. And we can stop that as well now. So if we go into this Discord, I'm Ruby. So now, because it's open here, so this is a Ruby program at the moment. This is the same Ruby code you would write if you're running it on Ruby. But because we're running it Xia, IronRuby, we can take advantage of the entire .NET platform from within this classic Ruby language or Ruby framework. So, as an example, in this particular example, I want to just output whatever the machine name is to the web page. So instead of hello world, I'm just going to return the machine name. Now in .NET, I know that's quite a simple task. I just go into the environment object and it's got it there. In Ruby, I'm not quite sure how you do it out of the box. I'd have to go off. The fact is, I'm Ruby, it's irrelevant because I can just say, you know what's easier? I will just use the .NET version. I know the .NET framework, I'll just use that instead. So I can require mscalllib, and I'm doing it via the interactive command prompt at the moment because I can't quite remember the syntax. So I think it's in system, and I think it's machine environment and machine name. Okay, so it's not. So we can play around a bit. So I think the other alternative is that we can come into here, and then we can just say, what are all your methods? That's not very neat, so we can come in and, ooh, thank you, Windows 7. Got puts, and then we've got a list of all the particular methods on that object. And this is how we can start kind of just having them play around, kind of inspecting the objects, just using an interactive console to actually learn how the framework works, how things behave. So just looking down the list, we've got a machine name. So instead of doing that, I can go machine name. and then it will return pretty. If you see my laptop, you'll know that it's a MacBook Air, which is very pretty, hence the name of the machine. Yes, I am that fat. But, so I've used the interactive prompt to actually figure out which methods to call and actually work out the Ruby equivalent. And notice, if you look at the machine, the method actually called, that I used machine_name. Now, if you've used this before, you'll know the actual method in .NET is machine name, without the underscores and camel cased. This is where IronRuby, again, comes into its own, because the team don't want IronRuby developers to have to think differently. They want IronRuby developers to think as they would. The IronRuby, or the Ruby convention, is all lowercase with the word separated by an underscore. And as such, they've done a translation between C# method names and .NET Ruby method name equivalents. And at runtime, they do this mapping and they do this translation. So this means that you can pick up any .NET assembly and it works in exactly the same way as you would expect it to work if it's a classic standard Ruby assembly. If, however, you're like me and you're a .NET developer and you're stuck in your ways, then you can still go machine name and go directly to the classic original C# method and still interact with it. Two different entry points for two different types of developers, with the language doing the hard work to do the translation for you. So now we've actually gone off and we've kind of learned what we need to do. We can come back to our application, we can go require MS core lib, and we can go get, we'll just add another endpoint, and we'll just return system environment dot machine name. Come back to here, or come back to here, exit out that. Let that be back up. And even though we're using the equivalent, the Ruby convention, or sorry, even though we're using the C# convention, it doesn't actually matter. The application and the framework doesn't care because that's all taken care of from the framework. So if we hit the actual endpoint, then you can see this Ruby framework has kind of interacted with the .NET framework seamlessly. It doesn't matter now. It's just one language kind of covers everything. So that's one nice thing, and it works in exactly the same way for Ruby on Rails. So if you are a Ruby on Rails and you want to start using Ruby on Rails but interacting with maybe some legacy code, so if you've got some business logic or you've got maybe a data access layer, but some developers want to use Ruby on Rails, then you can still reuse all of that code, but you can plug into the Ruby on Rails bit where it's actually required. Also, with things like Azure, Azure is going to run Ruby on Rails, or it's going to run IronRuby, which as it runs IronRuby, then it will run Ruby on Rails. So you get this nice little interop, and you can work with different parts of the system, reusing different assemblies and different parts and different components. And the fact that you're writing in C# or writing in Ruby it's less dependent. It's less important now. But again, that's kind of nice. But where I think Ruby is really powerful is the fact that Ruby has got some amazing testing frameworks. Ruby, one of their key things is readability, but it's also testability. Their community has kind of definitely changed the way we test applications. They've definitely made some brand new concepts and been some influence in how we should go about testing our applications. This is starting to come through into C#, but C# is limited by the fact that we have to kind of use C#. We have to write, and we're constrained by the type of language we actually can work with. The things like types, where we have to define them, is when you're using test code, more limiting, it's more constraining. Things like mock objects are required because, well, it's C# and you have to actually mock interfaces. You can't just mock any method. Within Ruby, you can simply just go, well, on this concrete object, there is no type, so just mock that particular method call, override it. C#, because we're constrained by the static type, makes life more difficult. With IronRuby, things are different, and things are different for the better. So if we close this and we close that, cool, okay. So what I'm going to do is that if I start a new thing, so I've got this C# class. It's quite simple, but it kind of proves the point, shall we say. It's simply got a property, and it's got a method, and the method increments the property. It's a classic example. Now, within IronRuby, I want to test this functionality to make sure it works using the Ruby frameworks. Now, the best one is called RSpec. RSpec is probably the best testing framework currently available. It's focused on behavior-driven development, and it's focused on, it's kind of providing examples on how your object should work. So you're describing the actual behavior instead of describing the actual functionality, and instead of describing the actual implementation. You work at a higher level. Already, by using BDD, your tests are more readable because they're focused on behavior, and as such, it just makes everything a lot more readable. That's a bad excuse, but there we go. With C#, people are trying to do it, but the behavior is lost, and making the behavior readable is lost because it's C#, as I'll demonstrate. So if we go require, and in this case it's C#, let's go bowling. This is just a helper class I've created. All it does is go off and actually reference the actual .NET assembly which has been built, but I couldn't be bothered to type that in. So I just created a nice helper class. And if I go right to the right sheet, so then we need to again require Ruby gems, and require spec. So we've now got all the frameworks and all the dependencies we actually require. We can then say, well, I'm going to describe the bowling class, and this particular test is going to be this defines the bowling game. So that's kind of like our if you think class, which will contain all of our different behaviors. And within this, we can do it should score 0 for good to game or pure or not very good. So now we've just defined a method, and this is actually this is something which we will execute, and this will verify the pass-fail behavior and actually verify if the code is working as we expect. Before we can do that, we need a before block. So before each of the tests actually get executed, execute this block of code. This block of code will simply create our bowling object. So this is the one which I showed you. So that will actually create this object with it before each test is executed. And then we can do 20 times so now we're just doing a loop, which is saying for 20 times call this method. So again, this nice little readability about having to use numbers actually improves the code, makes it a lot more readable. We can then actually do .score. So this is our property. And Ruby, in a similar way to C#, has got extension methods. Ruby can also extend the object and extend things dynamically. So it's added an additional method for us called should. And then we can say it should equal 0. We can save this and come in. We can go spec bowling. And this will now use the actual Ruby framework together with the Ruby code we wrote, and we'll test our C# implementation. It takes a bit of time at the moment, but as you can see, once it's actually kick-started, then you can see we get the nice pass-fail result, and we actually have our Ruby code testing our C# code. I think this is extremely powerful because now we can take advantage of this framework, this behavior-driven development framework we have in place. For example, we could output the format as HTML, redirect it to test.html, and let that do its thing. So again, this is just running the test again, but now producing a much nicer report for us. So now if we load up test.html, then we get a nice report. Again, this could be done in C#, but not in the same way, and we'd have to reinvent the wheel. We'd have to make an equivalent framework using the C# language. This requires time, this requires effort, and someone to maintain it. Because we can take advantage of this well-established Ruby framework, which has already got huge amounts of functionality, we can just, as C# developers, kind of go, excellent, we are now 3 years down the line of where we would be if we didn't have IronRuby. This is where I think it's extremely powerful. If we drop out of here and go into my Mac. So this is just some Ruby code I wrote. This is actually, again, just a Ruby implementation, but you can kind of see how things are starting to be structured. So we're describing a controller within Ruby on Rails. We've got a before block, just the same, and then we've got some behaviors, and it should do this, it should do this, some more code. This is how I imagine we're going to be testing our C# code in the future. Having this nice structured approach, using a Ruby framework, and taking advantage of all the readability and all the capabilities, but writing our actual main core application within C#. IronRuby will take advantage of the nice interrupt. We can take advantage of all the capabilities, the nice fluid interface, the nice fluid backwards and forwards approach between .NET and C#. Everything just works. For us, we can just come along, pick up either any Ruby framework, or a Ruby developer can come along and pick up any C#, .NET framework, and life will just work together. Everyone will be happy and kind of just in a big happy, one big community, and everyone will just have no language wars again. Maybe, anyway. I'm sure there will still be some people going, you should use Ruby and you should use C#. So, that was reason number 4, or that was obviously reason number 5. Finally, reason number 6. If you are writing a C# application, you can embed the DLR and IronRuby into your application. It requires 5 lines of code, and 1 line will declare which code you want it to execute. Simply create an engine, you create a scope, so it can store any variables and any methods declarations. Create a script source, so it can actually have some awareness about the code and it did all the parsing. Call execute, job done. That's IronRuby and the DLR hosted within a C# application. The result is I embedded it into a Redgate product called SQL Data Generator. So you can actually build business rules and add some scripting capabilities to the application, which affects the type of data which you actually want to execute. This means that instead of just having a flat input-output, we're now giving the control over to the user so they can actually control how the program works in a nice sandboxed environment. I've done the same for Reflector. So Reflector dissembles all the .NET code and allows you to see the code. Well, with the Methodist add-in, it will also allow you to interact with that code. So you can use Python in this case to see the code on one panel, but in the second panel, create instances of that code, call the methods, pass in different variables, and see how it's actually being executed, all because of the DLR. Finally, Resolver Systems in London have built a commercial product based around this concept. It's a programmable spreadsheet. Instead of having to create their own scripting language, such as VBA, they said, well, we're going to take the power of Python, use the entire Python language, all the frameworks, all the different tools and capabilities it offers, and embed that into a program. Then we turn the power over to the user, because we give the user that control and that power and that flexibility, or leave it off DLR, IronPython, and IronRuby. So, I think IronRuby will change the world. Maybe. It's certainly changed my world. I certainly think look at things in a slightly different way. I always think, well, maybe we can use IronRuby to test things now. Maybe we can use IronRuby to develop an application and just use C# to provide the back-end functionality. I think it's changed a lot, and I can see things as it progresses will change even more. The question is, how will it change your world? So, with that, thank you for your time, and if you've got any questions, then I'll be happy to answer them. Cool. Yes?
How do you package it up if you want to send it on to somebody and you don't want them? Everything I've seen so far is just in a plain text file at the moment. If I'm concerned about what other people might do with it, I don't care, I'm not going to store any shared secrets in there, or maybe I will. How do I package that up into something they can't read?
So if I understand the way the IronPython guys are doing it, they are creating a C# wrapper around it and hosting the DLR, and then hosting all the script files within that assembly as embedded resources. And then the actual application, when you execute it, all it simply does is goes back to that 5 lines of code, and then it will just call execute on the initial Ruby starting point, and then that will kind of cause the rest of the application to happen. Then everything as an embedded resource, and it's Ruby, you can use Reflected to get at it, but it's still a nice single executable, and you can share it amongst DLLs and separate. So I think that's how people will solve that problem in the future.
Ben, can you repeat the question?
Sorry, yeah, the question was, how will people package up the Ruby code so you can't hide the secrets and as such, and yeah, sorry.
My question is about kind of same but with different scale, is about the deployment, because I was listening and you were saying that you can use existing Ruby, like Ruby on Rails or other frameworks. On the other hand, we can use C# or other assemblies. Now, how much is dependent on .NET framework, and can we, what kind of deployment structure it need to deploy on a user machine, so we can assemble a complete product and send it to you?
Okay, so the question is, how can we deploy IronRuby-based applications onto an actual end-user machine? There's different kind of concerns with that. If you just want to package up IronRuby as part of your actual application, you simply reference 3 or 4 DLLs. You reference the DLR, and you reference the 2 IronRuby language implementations. That's it. That provides the core functionality. If you want to also bundle things like the Ruby frameworks, then you don't need Ruby installed. IronRuby will take care of everything because it is just it's an implementation of the actual language. So you don't need Ruby, if that makes sense. You don't need the traditional Ruby, you just need IronRuby. So in which case you just bundle up any frameworks which you want into a way which the actual IronRuby code could find them, and then you just package it up together and then put it onto an actual end user's machine. So there's a few issues, but if you're it's not very difficult to overcome those issues. Did that answer the question? Okay, cool. Yeah.
Is it any database support?
Database support within IronRuby. So at the moment, you get Active Record, or you can use Active Record, which is what Ruby on Rails uses. So that gives you PostSQL, MySQL, SQLite, all of those. In terms of SQL Server, the IronRuby team have created an adapter, so you can use IronRuby and point it at SQL Server database, and it will use the SQL client within .NET to do the actual hard work. So it levers the advantage of being able to use the .NET framework to its advantage, and it goes, well, we'll just create the wrapper around the SQL client and then provide that to Ruby on Rails. And that's how it's doing database support at the moment. So yes, it's there, ready and waiting. Cool. If there's no more questions, then I guess it's back over to you.
Well, we did talk about a giveaway.
A giveaway?
Yeah. So as you guys know, we give away something every month when we're here. This month we're giving away a ReSharper subscription. And I was hoping that my man here would be able to ask the audience a question or give out the prize based on the best question, not mine.
I'd go best. Actually,
Or maybe you've got something to test to see if they will listen.
It's always fun, isn't it? So I tested a nice lightweight web framework as one of my demos. Did anyone catch the name of what it was?
Sinatra?
There you go.
I'll
Job
see
done.
you during the break, and I'll take your email address and we'll get that sorted for you.
Thank you.
Okay. All right. Thank you very much to Ben. That was a great presentation.
You're welcome, mate.